Okay, in 6-8, expanding a binomial and the Pascal's triangle, we are only going to cover objective 1, which covers example 1 and example 2. We are not going to do example 3 and 4. So don't look ahead in the book and get confused. If you do look in the book, don't think that we're going to do more of that. Uh, that's for something else. So, or for a later time, I should say. Well, there's this really cool French mathematician named Blaise Pascal. They called him Blaise because he was a hot mathematician. I know it's kind of weird to think of a mathematician as being hot, but that's why they called him that. Not really, but it sounded funny. Anyway, he's not the first one to come up with this idea, but he is the one that's credited with it. If you look at a triangle starting out with three ones, and if you were to start every row of this triangle with a 1 and end every row with a 1 and find every value in between by adding the two values above it, you have what's called Pascal's triangle. Now, I don't have to put those connectors in there. I just did that to kind of show you what Pascal's triangle is. Okay, it starts with a 1. You take these two entries and add them together, and you get the one in the next row down in between those two. Add these two together. So we can continue to build this, which is super fun for many of you. I know, I've been there when I was a young lad. And we can look at rows of Pascal's triangle. Looks like I'm kind of going uphill here. 21, 35, 35, 21, 7. You'll notice that these rows are symmetric, meaning if you drew a line down the middle of the graph or of the triangle, you would notice symmetry values on both sides that match. You also know that the second entry and the second to the last entry are they actually call this the name of the row. So anyway, this is called the 0th row. This is called the first row. So that's the 0th row. That's the first row. Second row. Third row. So you'll notice that the names of the rows are sitting here and also here. Interesting fact. Now, if I were to ask you to expand x plus y squared, quantity squared, you know that that would mean x plus y times x plus y. Of course, you know, I'm a boxer, right? I'm gonna box this thing. I got x squared and I got xy. I got another xy, right? I'm matching stuff up. And finally, y times y, which is y squared. And so I would have x squared plus 2xy plus y squared. Well, what about x plus y to the third? Well, we know that's x plus y times x plus y times x plus y. Or we could look at it as x plus y times this thing right here. X squared plus 2x plus y squared. Am I still going to do a box? You better believe it, I'm going to do a box. Right? xy, I got x cubed. And 2x squared y. And xy squared. And x squared y. 2xy squared. And lastly, y to the third. That would give me x to the third plus 3x squared y plus 3xy squared plus y to the third. Take a look at those coefficients. Well, we had a 1 and a 2 and a 1. And we have a 1 and a 3 and a 3 and a 1. Oh my goodness. What do you see? Well, yeah, those are rows of Pascal's triangle right up here in my notes. I see those right up there. Okay, so I'm going to show you a way to use Pascal's triangle to do this expansion without all these boxes. Now, you can still do it that way, but I want you to, when you expand these things, we're not going to use boxes for these, especially as the powers get bigger. Now, if you go to the resource room or you talk to any of your other Algebra 2 friends or teachers, you're going to see that if they do it the exact way the book does, then I just don't like the way they do it because it doesn't organize the information. So I'm going to show you a way that'll organize your information. For instance, I need the third row of Pascal's triangle. So this is the row of Pascal's triangle that I need. One, three, three, one. Look for the name of the row, right? The name of the row is either the second or the second to the last entry of the row. Next, the highest power, I'm going to start, my two terms that I'm dealing with are x and y. Now it's important I noted that because when we get into a minus situation, you need to understand what the different terms are. But we have positive x and positive y. So I'm going to start with the highest power of x to the third power. And I'm going to count my way down. X to the second, x to the first. What is x to the 0? Let's write this over here on the side. X to the 0 equals 1. That's right. So I'm going to write down my 1. Now, I'm going to go immediately below this 1, and I'm going to start with my second term and raise it to its highest power. And I'm going to count my way backwards in decreasing order until I finally get to y to the 0, which is, again, 1. Now, I want the product, not sum, but product of these three things. And if you multiply 1 and x cubed and 1, you get x to the third. If you multiply 3 and x squared and y, you get 3x squared y. If you multiply 3 and x and y squared, that's 3xy squared. If you multiply 1, 1, and y cubed, that's y cubed. Oh, look. No boxes in order to do that problem. But I got to the same place. So, row of Pascal's triangle is first. Start with the highest power of the first term. Count your way down till you get to the 1. Drop down. Then you have y to the second term to the highest power. Count your way back. Multiply down the column. Multiply down the column. Multiply down the column until you get to the end. Alright, let's try this. Now this is going to be a little bit more challenging, right? You have two terms, 2x and negative 3y. We need the fourth row of Pascal's triangle. 1, 4, 6, 4, 1. We've got 2 to the x raised to the fourth power, 2 to the x raised to the third power, 2 to the x raised to the second power, 2 to the x raised to the first power, 2 to the x to the 0, or 2x to the 0. Why did I keep saying 2 to the x? 2x. Then I drop down and I have my second term. Now keep in mind that minus goes with the 3. That is important. And a minus 3y to the third, and a minus 3y to the second, and a minus 3y to the first, and a minus 3y to the 0 is just 1. I'm going to multiply down the columns. Pay attention to what's going on here, folks, because this one is a little bit different. I do not have 2x to the fourth. I have 2 to the fourth x to the fourth. So that is 16x to the fourth. I know several of you are going, wait a second. Remember, you are distributing the exponent on the outside to all the exponents on the inside. Well, same thing's happening here, right? And here, although 1 is not that eventful. So we have 2 to the third, that's 8, times 4, that's 32, times negative 3, which is negative 96. We also have x to the third and y to the first. Here we have 2 squared, that's 4, Negative 3 squared, that's 9, and so 4 times 9 is 36. And 36 times 6 is 216. So positive 216, because the negatives canceled. X squared, y squared. We've got 2 to the first times 4, that's 8. 2 times 4 is 8. And negative 3 to the third is negative 27. So 8 times negative 27. 8 times negative 27. That is negative 216. So that is negative 216. We've got x and y to the third. And lastly, 1 times 1 times, well, negative 3 raised to the fourth power, is 81. And then you have your y to the fourth. There you have it. Just multiplying straight down the columns. Be careful when you do it.